Hello, everyone. Thank you very much for the introduction, and thank you for inviting me to speak in this workshop. As it was mentioned, I will hold my presentation in English since German is not my first language, so I hope that's all right with you. So my presentation is very simply put a report of a 5-month-long progress of building up a newborn digital collection within a very traditional technical museum, which is the Vienna Technical Museum. So as we all probably know, most cultural institutions and museums are currently experiencing a big shift and changes into their traditional role of collecting and preserving cultural heritage. This is because historically museums have taken on the role of preserving physical objects, but when they were planning their initial collection preservation strategies, they couldn't have predicted the advances of digital technologies would have on their method of collecting in the future. So the Vienna Technical Museum is one of the many traditional museums which are currently facing the challenges of collecting and preserving born digital objects, and also to advance their established strategies to collecting, conserving, restoring, documenting physical objects in order to start collecting born digital and their dependencies. So, in contrast to physical objects, born digital objects can only be comprehensible through the application of very specific software and hardware combination. So for this reason, these dependencies also have to be somehow collected and preserved for the future. A very simple example of this problem can be shown on the basis of a Schultes washing machine from the collection of the Vienna Technical Museum, which used to run on a binary program stored on a punch card. So without the necessary software and hardware, which would be able to read these binary instructions and to translate it into a more contemporary language, a human understandable language, this program remains to be collected within the museum as a physical object rather than a born digital program. Similarly to this punch card that I just showed, there are also many other born digital objects that remain undiscovered within the collection of the Vienna Technical Museum, stored somewhere on an internal hard drive or on an obsolete data carrier, and are just waiting to be rediscovered and made comprehensible again. Because born digital objects so heavily rely on software and hardware dependencies, which are technologies that are advancing very fast, the question is not whether or not these technologies will eventually fail and become obsolete, but when. Because of this reason, the Vienna Technical Museum is really experiencing a time pressure of finding new ways to substitute certain software and hardware dependencies through emulation, and in order to preserve these born digital objects for the future. And lastly, because of the overall necessity of the Technical Museum to expand their established collection digitally and to prepare for the next challenges of collecting digitally, a new department for collecting born digital objects was established in 2021. This collection is also part of the Research Institute, which is also newly established last year, so in 2021. So in my presentation, I want to show you the progress of how the Technical Museum approached these challenges by setting very specific goals for building a born digital collection, and how I approached to solving these goals or achieving these goals, what research questions I developed along the way, and what our next steps are going to be in the process. So the very specific goals that were set by the Technical Museum were to build a collection of born digital objects and their dependencies, which are either hardware that is already collected within the museum or that rely on contemporary technologies that haven't been collected yet. The second goal was to develop an internationally coordinated collection strategy focusing on collecting born digital objects that are specific to the Austrian cultural heritage and that have not been collected anywhere else. The third goal was developing a preservation strategy for born digital objects and their dependencies, which also included developing a new documentation and risk assessment approach. The fourth goal was the participatory expansion of the collection by visitors and online users. And the last one was researching suitable formats for the best possible communication and use of the collection in the future. So in contrast to physical objects, born digital objects have very specific characteristics in terms of their preservation. For these reasons, they mostly demand more complex and experimental preservation methods. And because there is no established methodologies in the field of museology, when it comes to the preservation of such objects, I used established methods from different fields of study, which included the computer science, digital preservation, conservation, restoration of software-based art, archival practices, library science, and so on. And because developing a new collection from the ground up is such a complex task to begin, I decided to select 3 case studies which would best demonstrate the issues of building such a collection. These 3 case studies are: the first one is the estate of Vladimir Nabokov, who was an experimental photographer and designer. His estate includes his personal computer, which he built himself, a collection of discs that are different formats and from different eras of his work. And these discs include his original working materials as well as software. The second case study is a dynamic browser-based game that's called The Count, about the Austrian right-wing radicalization of the youth. This case study is complex in terms of its preservation because its dynamicism is created by the server performance. And there has not been a lot written about how to approach server-side preservation, so we had to develop our new approach towards preserving such a game. And the third case study is a hybrid object that is composed of an experimental game and a web project from the early 2000s by the pioneer of experimental game design, Margarete Jamann. So a successful preservation strategy really relies on the technical possibilities of preservation. But before going into the technical details of preservation, we really needed to ask ourselves the question, a very basic question: what part of the born digital objects do we want to preserve? Do we want to preserve the functionality of the born digital object? Do we want to preserve its original source code? Are we interested in collecting all of the dependencies, or can we find certain emulation to substitute these dependencies? So in order to answer these questions, we applied a method which is commonly used in art fields, where you technically and conceptually deconstruct an object into each component. For each component, then you have to decide what their significant characteristics are, and to evaluate which part of these components can be replaced in the future in order to set priorities in the preservation process. To make this process more systematic, a new documentation and risk assessment method had to be created for this purpose. So as you will see in the next slides, for each case studies, we applied 4 different preservation methods that are very broadly applied, which are migration, emulation, virtualization, and containerization. And for each case study, we used a combination of multiple tools together. So the first case study, the estate of Vladimir Nabokov. Vladimir Nabokov, as I said before, was an experimental photographer and designer. He's probably best known for writing visual computer programs using the Visual Computer Language Basic. He also published a book about it where he writes the process of writing these codes, how he approached it in order to create three-dimensional computer-generated objects. So after his death, his personal computer, along with his floppy disks and zip disks, were donated to the museum. And because of the museum's policy, no one has ever attempted to bring this computer into function and to make a copy of the data. So it has stayed almost as if in a time capsule from 2007 ever since it was donated. But when we were doing our research about his programming process, we really got to know how he approached things. And because we were interested in preserving his whole system that is located on the internal drive, we were researching how to apply disk imaging in order to preserve his computer as a whole system, so including the operating system, certain libraries, data, and everything that's on it. The same approach was applied to the floppy disk and the zip disk. So the two research questions we had to ask ourselves in the first case study was, how can born digital object be collected from obsolete physical storage media as an entire system? And the second research question was how to develop a digital workstation for disk imaging and for forensic data analysis. So there was not a lot of research found on Vladimir Nabut-Lieven, so we are still only speculating what we will find when we disk image his internal hard drive and floppy disk. But we know that for each floppy disk, we will need specific drives, specific hardware, a specific operating system and drivers to launch these drives. And we were also researching forensic hardware to ensure the integrity of the data when we start the process of disk imaging. So this is the schema or a plan for the disk imaging process, which I developed in order to make ground basis to build a digital workstation in the future. Second case study, the Count. So as I said before, the Count is an interactive browser-based game. What makes this born digital object difficult to preserve is the fact that its dynamic parts are generated by a WebGL server configuration. Because of this, you cannot really apply standard web archiving or web collecting methods like a crawler to preserve this game or preserve the functionality of the game. So new methods had to be explored. For this reason, I tested container technologies, more specifically Linux containers, in order to create an encapsulated, locally hosted environment where I installed the necessary application. Because we were lucky enough to collaborate with the developers of the game, and they gifted us or donated us the original source code and the server configuration files and media. We were able to push this data inside the container in order to create a locally functioning game. So this method proved itself to be very successful, but still I had to ask myself the research question or whether or not container technologies are a suitable format for the preservation in the future. When I was doing my research, I found out that a lot about this was written in the fields of computer science because this is a very contemporary practice software developers use to deploy their software. So they use containers like Docker or Linux containers. And there has been written about the possibility of emulating container runtime in the future. So this is a method that we are definitely exploring as a long-term preservation method for containers. So this is recording of the locally functioning, as you see on the IP, it's a locally functioning game. And this is what it looks like. And currently the game is not available. I don't know why, but the developers took it down from their original website. So it's preserved in the Technical Museum. Okay, the last case study is, as I said before, is a hybrid game from Margarete Jaman and Max Moswitzer, who together formed the Mamex collective. It's called the Nivel Engine Tools, and it is a hybrid because it was made in different iterations. So this is one part of it. It's a website, and as you see, you cannot really, the software that is used to render animation that should be shown are not supported anymore because the Adobe Flash Player is no longer supported by contemporary browsers. So I was exploring new methods of preserving the functionality of the website with its original performance. For this, I used very established web archiving tools such as Conifer and Heritrix. And I also used the browser emulator that was also developed by Rhizome, and it's also one part of Conifer. And what makes this project also interesting, you can't hear the voiceover and because it's a GIF, but it includes a narration from Heinz von Vossner, who was an Austrian philosopher and physic. And I think it's a very unique project where you don't really see a physics contributing to. So this is the second part of the case study. It is an experimental game where the developers actually use the first iteration of the game engine called Unreal Engine and the first-person shooter called Unreal. And what they did was they took the original source code and they modified it in order to create some like distorted 3D spaces and for people to openly contribute to this game. And the original source code and modification data was actually gifted to the museum on an optical disc. But this is not enough, like to preserve only the source code is not enough. So we are currently collaborating with the developers to find like a new way of documenting several iterations of this project and to document the technical history of this game. For this reason, I made a media wiki, which I found is becoming a very common method of documenting software-based and time-based media projects in order to actually document the software and technical dependencies, but also to show different iterations of the work. So these are the advances I've made so far. The question is, what's next? So what we are going to do in the future is to develop a more comprehensive strategy for the preservation and collection of born digital objects and their dependencies, to test different data analysis tools and storage opportunities, to develop a cataloging system to link existing objects from the collection and their digital dependencies, approaches of documentation, and through interdisciplinary work with the Technical University and University of Arts and industry in general, we want to start collecting also other different born digital objects and to find new solutions of the preservation. And lastly, to develop a metric for a risk assessment of born digital objects, because again, the museum only has a risk assessment approach for physical objects, which doesn't entirely apply to born digital ones. So my goal for this presentation was to start a discussion with professionals that work in similar departments and are on their way of building a new born digital collection. And I hope that we can exchange knowledge and collaboratively work to find new solutions. So thank you for your attention.